In 113 through 118, we're using that formula for the sum of an infinite geometric series that's given at the beginning of this section. That will be given to you on the final exam. So, in 113, we can recognize that this is a geometric series with an r value of -2. Since r is not between -1 and +1, that's not a number that's in between -1 and +1. The series does not converge or diverges. We will not find its sum if it diverges, because diverges means it doesn't have a sum. In 114, we do have a geometric series again, and this time the ratio is -2/3. We multiply by -2/3 to get from one term to the next term. And so since r is between -1 and +1, the series converges, and if it converges, we actually can find its sum. The sum is equal to the first term, 1/3, divided by 1 minus the common ratio, and the common ratio is -2/3. So now we have 1/3 divided by 5/3, which is 1/3 times 3/5, which is 1/5. In 115, we have an arithmetic infinite series, and because our common difference here is 3, we add 3 to get from one term to the next, and an arithmetic series never converges, so we'll say this diverges. In 116, we have a geometric series, and our r value is 1/4. Since we multiply 8 by 1/4 to get 2, 2 times 1/4 is 1/2, 1/2 times 1/4 is 1/8. An arithmetic series, or rather a geometric series with an r equal to 1/4, that r value is between -1 and +1, so that means that this series converges. If it does converge, we will find its sum. So the sum is equal to the first term, 8, divided by 1 minus the ratio 1/4. So that's 8 divided by 3/4, which is 8 times 4/3, or 32/3. In number 117, we do have a geometric series here with an r value of -1, since 3 times -1 is -3, -3 times -1 is +3, etc. -1 is not between -1 and +1. It has to be strictly between those values, not at either one of those values, in order for the series to converge. So this series diverges. If it diverges, we will not find its sum because its sum does not exist. In 118, we have a geometric series with an r value of 1/10, since we multiply each term by 1/10 to get each subsequent term, and that value is between -1 and +1, so this series converges. If it converges, we will find its sum, and so its sum is equal to the first term, 9/10, divided by 1 minus the common ratio, 1/10. So that's 9/10 divided by 9/10, which is 1. In 119 through 121, we're asked to find the sum of each geometric series in terms of x in simplified form, and then find the values of x for which the series has a finite sum. So this is a geometric series in 119. And our r value is -x/3, since x times -x/3 is -x²/3, and -x²/3 times -x/3 is +x³ divided by 9, etc. So this converges if that value is somewhere in between -1 and 1. If we multiply both sides by -3, this will give us 3 is greater than, x is greater than -3. Our sum is equal to the first term divided by 1 minus the ratio, and the ratio is -x/3. So this is x divided by 1 plus x/3. Let's multiply both top and bottom of this complex fraction by 3, and then distribute to both terms in the denominator, and that will give us a sum of 3x divided by 3 plus x, and that will be 4 values of x that are between -3 and 3. That would be when this series converges to a sum. In 120, we have a geometric series with an r value of x minus 3, and so this series converges when the r value is in between -1 and 1. I'm going to add 3 to all three parts of this inequality, and we get 2 is less than x is less than 4, and that's our interval of convergence. The sum is equal to the first term divided by 1 minus the ratio, and I'm going to use parentheses around the ratio to aid in simplification. So s is equal to 1 minus x plus 3, or the sum of the series is 1 divided by 4 minus x, and that's 4 values of x that are in between 2 and 4. In 121, we do have a geometric series with an r value of 5x. Since x squared times 5x is 5x cubed, that times 5x is 25x to the fourth, etc. So this converges when r, or 5x, is between -1 and 1, and that means that x is between -1/5 and +1/5. The sum of this series is the first term x squared divided by 1 minus the ratio 5x, and there's nothing to be done to simplify that one, so this is 4 x values that are between -1/5 and +1/5. In the last few exercises, we're going to use our knowledge of geometric or arithmetic sequences to write an equation to represent each of the following situations. We can also use a table here if that helps. In 122, the number of students in Parish Upper School is 425 in the first year and increases at a rate of 3% per year. Write an equation that models the relationship between S, the number of students, and T, the year number. So let's make a table here. So in the first year, T equals 1, the number of students is 425. And if we increase at a rate of 3% per year, in the second year, there would be 425 students plus 0.03 times 425. Now, if we factor the 425, that's equal to 425 times 1.03. So every time we increase by 3%, the amount becomes the previous amount times 1.03. So in the third year, that would be 425 times 1.03 times 1.03, which is 1.03 squared. So that means that S, the number of students, is equal to 425 times 1.03 to the t minus 1. Notice how this looks like the general term for a geometric sequence with a ratio of 1.03 and a first term 425. In 123, I'm going to create a table again. The number of students in the upper school is 425 in the first year and increases at a rate of 5 students per year. So in year 2, the amount of students is 425 plus an extra 5. In the third year, we add another 5, which means we're going to add 10 to the 425, or we're going to add 5 times 2. Well, in the previous year it was 5 times 1, and the previous year 5 times 0. So what you're going to notice here is that S is equal to 425 plus 5 times the value of t minus 1, which looks an awful lot like the term formula for an arithmetic sequence with a first term 425 and a common difference of 5. So we can simplify this one though. That's 425 plus 5t minus 5, and so the sum is, or rather the number of students is equal to 420 plus 5 times t. In 124, a car is worth $42,000 during its first year and loses value at 19% per year. So our first column in the table is T, and second is V for the value of the car, And if the car loses 19% per year in the second year, its value would be 42,000 minus 42,000 times 0.19. And if we factor out the 42,000, that will give us 1 minus 0.19 in the parentheses, or 42,000 times 0.81. What this means is this is going to be a geometric sequence with a first term of 42,000 and a common ratio of 0.81. So the value of the car is equal to the first term 42,000 times 0.81 raised to the t minus 1.